we've now got all of our analytics events firing inside of Unity. So that means we can now jump over to Spark.
Woo!
Back into Spark and do stuff. So,
Nice.
Yes, very exciting. Very exciting indeed. Let's go into our community.cloud.databricks.com and open up the notebook that we had earlier. There's a bunch of stuff in here that we don't need anymore because we've already mounted the AWS S3 bucket. We don't need this code anymore, and we sure don't want to be sharing these things around. So let's... if you click on delete in the top right hand corner of each individual cell, it'll say, do you want to really do this? And you say, yes, I am aware that I want to close that. And it goes, no troubles at all. Then also you can hold shift and click on the close button and it'll just get rid of it altogether.
Oh, what?
Without whinging at you. So this one I don't need anymore either. I am going to quickly take note of the folder that I was in because this was the application ID that AWS Mobile Analytics had set up for me, and I have to have 2 of them because my other one was already there, so we'll get rid of that as well. And here we have the loading of the JSON data. So let's call this something properly. Because we are loading this into a data frame, which is essentially a table that we talked about earlier, we should call this, let's call it DF...
Data frame JSON.
Yeah, I'm not going to call it JSON. I'm just going to call it...
DF Analytics.
DF Analytics. DF Analytics. All right, so it's been a while since Josh and I... Josh? Why did I call you Josh?
Josh, sick one.
Sorry, Nick.
Whoa. Whoa.
I feel like I should just record this whole
What?
video again now. Anyway, let's
Josh.
I'm sorry, dude. I'll buy you a coffee.
Yeah,
You can call me names throughout this whole thing as well.
I will.
All right. Okay, because it's been a while since Nick and I had been here recording, I made sure I got it right that time. Oh my goodness, I'm so embarrassed.
Thanks, Jeremy.
Our cluster has gone ahead and shut down. The free cluster, the community edition cluster, if you don't touch it for, I think it's 2 hours, it'll just turn itself off. So let's go ahead and create a new cluster. So last time we did it by going to clusters and creating. If you're already in the notebook, you can go straight to the top left and say create a cluster. And what do we want to call this one? Can we call it Josh?
Yeah, let's call that one Josh.
Josh. So Josh the cluster, you can see our Geralt has terminated for inactivity. Alright, so now Josh is spinning himself up. We can go back to our workbook and into our workspace to open up our notebook. And then when we come here and say attach to and click on it, it's still pending. As soon as Josh is ready, the notebook will just be connected to it and we'll all be happy.
Sweet.
Alright, so this is going to load up all of the analytics data from our bucket and from our folders. It's up and running now. Hooray. Let's jump over to our S3 bucket, which was in AWS Unity Analytics. From here, we'll jump into AWS Mobile Analytics, into the events directory. It was 25909 was the end of...
I just listened to 47C7.
Yes. 2 ways to attack the same problem. Everyone is winning.
Yeah.
Now we are in July, and it is the 2nd of July.
Wow,
and
quick.
Sorry?
That went quick.
I know.
Yeah.
It really is July already. Oh my goodness. Moving on. All of the data that we have been capturing and setting up in the last few videos has already reached here. So if yours hasn't reached there, then chill out, get a coffee, whatever you want to do, get some lunch. But your data will eventually get into S3. So in here we can see that ours is up to date. And we've got lots and lots and lots of little individual files.
Yes.
Rightio. But when we come to our Spark and we say read the JSON from that directory and say year, month, day, hour, all the files in those directories. What it's also doing, well, what I want to do is I want to show a little bit more about Spark, and let's actually learn Spark now that we have all the data. So I'm going to turn off this cache, and let's load that data. And then we'll chill while it does it. And then we'll chill while it does it. And then we'll chill while it does it. And while that's doing that, I'm going to come down here to display the JSON data, and I'm just going to call run it.
It's called Def Analytics.
Yes. Thank you, Nick.
Plus, it probably wouldn't have displayed even if it hadn't finished reading it first.
No, that's the cool thing. You can just go, you know what, that one, and this one, and this one. And it just adds them all onto the queue.
Yeah, but... Oh.
So you can have lots and lots and lots of little queue things that are all ready to go. Now it's erroring at me because I've renamed it in one spot, but not in the other. So I'm going to come down here, and that one will now be able to work. And then we come here, and this one will now be able to work because this one's renaming it to that. So let's just quickly run these. So the context of what we've actually just done. We've said go ahead and load up all the data, and it says no troubles. I took 26.69 seconds to load up all of the data. That's actually wrong. It took 26.69 seconds for it to scan over through all of the files in the subdirectory and find out what the schema of the data frame actually is. It actually didn't load any data into Spark.
Oh.
Spark is a lazy loading application. So when we come here and we say display, look, it took 5.2 seconds for it to actually go back to those files, load them all up, then give us the data, and then it forgot about them all straight away. So if we run this again, it should take another 5 to 8 seconds for it to run. As it goes through all the files and gets it back out again.
But if we cache it, then it's going to be super quick.
Yes. So if we cache it, we'll add a new cell into the middle between these two. So I'll just go plus. And we'll say put the correct data frame name in there. And we'll cache it. Now, cache, you go, hey, you loaded everything into memory. No, it said, I will now, next time the data comes into Spark, I will not release it. I will remember it. So that means this one here, the data hasn't actually reached memory, so it's going to take a few seconds for it to get in here. And there we go, so 3.7 seconds. But now when we run it, it should be super duper mega quick. Look at that, already done, took 0.4 seconds.
It's pretty good.
So the data is now in memory. And we can just keep on running that, and we can run as many queries as we want to. And it'll just keep on going. So you go.
So that also means that if new stuff is added to the S3 bucket, that it's not in memory at the moment.
Correct. So we have now just said take the data frame as is, keep it in memory. But as new data is being entered and more players are playing the game, Spark is not going to go and load all those new events.
So then I would have to run the cache thing again.
You would have to release it from the cache and then reload the data.
Oh, okay.
But you don't have to do that. Who says you even have to cache it? If you wanted to have constantly up to date analytics data available to you in Spark, you could just keep on running this. And now it's going to take longer and longer and longer as you get more and more data. But whenever you run a command, it's going to go to S3 and look up whatever is in S3 at that particular point in time.
But then what's the point of caching it?
Well, it depends. What type of queries are you going to be running? If we're going to be running queries, so this is a big data tool. We're expecting, we've got very small amounts in here right now. We've got 1 to 2 meg, if that.
Yeah.
Let's say you've got 10,000 players and they're all sending off 100,000 events every single day.
Yes.
So now you're going to have a lot of data, and it's going to take you probably 10 to 15 minutes to run that first query. And you go, now I've got 6 queries to run. So you run your first one. Oh no, I've got a syntax error. And it's going to have to forget all the memory and then load it up again. So as you're iterating, as you're trying to develop, it's going to get harder or longer and longer and longer per query for you to run. Even though it's the same query every single time, because it's going to go to S3. You're going to say, run this command against all of the data. And it's going to go, no troubles at all. It'll go to S3, grab everything, load it into memory, try and do the query. Oh my goodness, at the 99% mark, I've got a particular problem because the timestamp is actually not a timestamp. You've given me a string. So then it's going to go, well, I'm not going to give you any results, and it's going to crash, and then it's going to release all the memory. And you go, oh, there's my syntax error. You run it again. Now you have to load up all the memory again. Load up all the data into memory. Whereas when you say cache, you're saying, how about you don't forget it? You just remember everything that at that current point in time. And so, now you can query, and it'll query incredibly fast. So this comes to a question of what type of data do you need? Do you need up to the moment, or can you be happy with just a little bit of delay?
Fair enough.
So yeah, there's a fun argument there of how real time is real time. So when I hear real time, I think sub-second. But really, if I was working on an aggregate level to talk about how players are interacting with my game, I probably wouldn't care about how people were using it on that day because I've already got a few months worth of history that I can work with.
Yeah, fair enough.
So I go, I'm just going to work with what I've got today. I'll cache that, and I'll do whatever queries that I want.
That makes sense.
Yep. All right, cool. So let's talk a bit more about some actions and transformations. Now, this is not a Scala course. However, it's easier to demonstrate this next part in Scala than it is to do it in SQL. But SQL works exactly the same way, and I'll demonstrate that after I've shown this. So let's put in a few more cells here. And I've got my DF Analytics data frame. And inside of this, I'm going to say .select. And I want to pick on arrival timestamp, just as an example. Come on, get in there. Click the cell. We can be friends. There it goes. I go dollars, quotes, paste in what I want, and now that'll go, no worries, I will select that for you. But look, it didn't give me any data right now. All it said was, I'm going to go and check that there is an arrival timestamp in the data set, in the data frame of DF Analytics.
Okay.
And it says, so now this is what the response is. And you go, great.
It's like the schema?
So this is the schema of what the return of this is. But it's just returning a schema. It's not actually selecting anything. So to do that, we have to go val df timestamps is equal to this, is equal to DF Analytics select arrival timestamp. And it goes, hooray, great, I've got it. So now we come to another cell and we'll say display. Whoa.
I do that too, dispally. I do that.
I was going for the 9. I didn't even notice that I did dispally.
Oh, I didn't even notice the
Display.
9.
2 ways to attack the problem. Thank you again, Nick.
Thanks, Jeremy. I needed to remember what I called you last time.
Alright, so as I run df display timestamps, now it says I'm going to look at what this guy is, which is actually this, and then I will display that to you. So look what this one said. It says, awesome, all I've got for you is a data frame with a thing called arrival timestamp, a column called arrival timestamp, which is of type big int. But now when we've said display it, it says I will now execute a job and I will return data for you. So there are transformations and then there are actions.
Okay.
So this is a type of transformation. Let's try a group by.
So,
whoa, yep.
So, let's say for whatever reason, I want it to be like, you want it to perform something on arrival timestamp, and you say something like, on every timestamp where it is even, I want to replace the number with 2. And then you want to put that back into the original data frame, or create a new data frame with that in it. How would you do that, or are you going to get to that?
I'm going to get to that using SQL.
Okay.
So we will answer the exact question, but in SQL.
Cool.
For now, I want to just keep on focusing on the transformations and the actions. So let's put in another example here, which is going to be, we should take a note of what you just said. Nick wants to
destroy all the data.
Timestamp. He does not want to destroy the data, otherwise you have to capture it again. I know the game's fun, but I'd prefer to get on with it.
Yeah.
Although you could just go into the S3 bucket and delete it with your account. Please don't.
Okay.
Nick wants to look at timestamp. If even.
Change number.
Change number.
I guess.
And
or
if odd. Say Gary.
Oh, say Gary. Yeah. Or you could. Yeah.
Let's go with that.
Yeah.
Change number to times 3.
Okay.
Multiply it by 3. And okay, so we're just keeping note of what we're going to go to later. For now, I want to keep on track with the transformations and actions.
Okay.
So let's put in here. Let's say group by arrival timestamp, and then we'll say dot count.
Mm-hmm.
So this is going to say Look at these arrival timestamps down here.
What?
Like, I haven't actually run this one yet. All I've said was just, hey, get ready to put this query into arrival timestamps. But look at the arrival timestamp here. So we've got duplicates. So if we say, let's take all the arrival timestamps, group them together, and get a count of them, we would then be able to let's look at this guy here. So 61384, assuming it's going to return back in any order. So now it's actually done that query and run it and popped it out. And so now we can see that we have a count of 3, a count of 20, a count of 20, so 27. So remember, AWS Mobile Analytics in Unity is grouping the sends together. So we might have 20 individual rows of data, like a click, a click, a click, a level start, a complete, a player spotted, then the next level.
But they'll arrive batched together.
Yes, because Mobile Analytics is going to group them together for us.
Okay. Cool.
All right, so then we can let's go a little bit further with this one. We'll say val df filtered is equal to, so now we can take the timestamps data frame and say filter based on, if I can remember what the syntax is on this, I hope this works, is equal to this one. Don't whinge at me, otherwise I'm going to be upset. Yes, great. So now it said...
What? That's a
big int.
It's a SQL command.
That is a SQL command. But we're running it through Scala. Yes.
I didn't know that.
So you can take all of those different selects and filters and where clauses and group bys and window function and aggregates, and you can run them through in Scala. So it's which way works for you to write.
Right.
But look at what's happened here. I've said take the original analytics data frame, pick just the arrival timestamp column. So now all this guy has is just the arrival timestamp and a count, because I did a group by. Now in this one here, I'm saying filter that timestamps data frame and only give me the one where the arrival timestamp is equal to that one. And I picked that one because it was the top one here. So now if we say let's show df filtered, we should only have one result here. And it does. So it's done that and given us just the 3. But, so, all it's doing here is these are transformations. It's saying group this, give me a count, filter it out. Don't actually execute any of that stuff until I actually tell you to do something. So this is quite interesting when we go into the Spark job and we'll say, what did you actually do to make that happen? And we'll expand out the Spark job. And it says, there's a few things that I thought I had to do. I found these two, and I thought I had to do these as well, but I skipped them all. And you go, cool, what did you skip? And it goes, I don't know. You could look at it and go view and find out, but really we're not going to pay attention to that because that's more magic stuff. What I do want to look at is this one here. So we can expand this out and see that it has 2 stages. So there was stage 32 where it had to do 8 of 8 things, and then there was another one where it had to return the data. So we go, that's interesting. What did you have to do in these things? So we'll go to view. And this will bring up the DAG of how it's going to work with what I had to do. Let's expand this one. And so now we can get into how did you do what you had to do to show me df filtered. And it said, well, I had to do some generation of code generation for you. I had to some maps to some partitions around. Then I had to do a table scan. Now I had a new set of data, so I'd better do another whole stage code gen to select more stuff out of it. That was the end of what I had to do. So there's the end of stage 32.
Whoops. Send it to the next.
Come back.
Partition.
Then it said, yeah, now I'm going to take that data, I'm going to pass it off to the next stage, which is now on stage 33. And then it did some whole stage code gen and some map partitions internal, and then it was displayed back out the results. You go, cool, what does all that mean? For the sake of this course, we're going to say it did stuff and gave us a result.
I like that. Results.
Yes, I do like results as well. But I will point out something here. When it says stage 32 and stage 33, what happened to stage 1 to 31? Every single time
All the ones before?
All the runs before. Yes, that's the answer. If you run this one, we will now be on 34 and 35.
Wait, no, it just ran job 32 again. Oh, what? 42?
Stage 42 of job 32.
Oh.
Ooh. but it gave us the exact same result. So let's do something else a little bit more fun here. If we put in an explain.
What?
So this is saying, how did you come up with what you said you had to do? Let's look at what it did. You go from the bottom part here and you work your way up. So it said I had to file scan the original JSON. Then it was in memory, so I had to go to look in memory. It was a table scan because it was cached and it was in memory. Actually, that's not because it was cached. It was now in memory. Then it did the filter, and then it did the aggregate. Hang on, it did the filter before the aggregate? But our query said you should do the aggregate and then do the filter.
I guess it's faster to do the filter first because then you don't need a calculator for every other thing, and it sort of realized that.
Exactly. So Spark has what's called the Catalyst engine, where it'll take whatever code you want. You can write it in whatever style you want, whatever works for you, whatever language that that Spark supports, and it will come up with a physical plan behind the scenes, and it'll generate all the Java bytecode that it needs to run for it, and go, there is the code that I'm going to execute for you, and I'm going to run this for you, and this is the fastest way that I can compute to do it.
It's pretty magic.
It's pretty darn cool. Oh yeah. So I think this video is going a bit long, but we'll do one last little part here, which is, let's take this exact same query, let's convert it to SQL, and we'll see what the physical plan looks like inside of SQL. I'm expecting that it should be exactly the same thing.
That's what I must say.
So let's add in another cell. And because this one is defaulting to Scala, I'm going to have to put %SQL. School. I'm going to need to... Did I do that temp table yet? Down here. Yeah. I did run it. That was the 7th of the 2nd, so it's already ran. I said take DF Analytics, make it so I can query it as a SQL object, and that table in SQL is now going to be called JSON data. Here we go. So now we can go.
I wish DataBricks had IntelliSense.
I really wish it had IntelliSense too. That would be super cool.
We should ask them.
Yeah, we'll write to the account manager and say, "Oi, can you help us?" Or is it in the line?
Great.
We'll see what they come up with. Maybe they can, maybe they can't. But if we want it. Alright, I'm going to run this. Now, if you're watching along, following along, and you don't know how to write SQL, that is perfectly fine. We're going to continue this example, and the next video after this will be an intro to SQL video.
Yeah.
Alright, so I'm going to say select everything from JSON data. I'm going to take the arrival timestamp column. I'm going to do a count star from, and a group by arrival timestamp. So this is going to, let's quickly just look at this one for a second. I do need a filter.
Oh, the filter's just aware. Oh.
So there's our 1384 that we were talking about earlier. Let's bring in the count. If we're doing a count, that's an aggregate, so I need to bring in a group by. There we go, and now let's pull off this guy here and put where something is equal to that, and the something is the arrival timestamp. And what are you whinging at me about? Group by, the group by should go after the where. There it goes, so there's the same thing, but if we run explain over this, it'll say, how did it come up with what it did? So it did a file scan JSON, in memory relation, followed by a table scan, filter, aggregate, exchange. Filter, aggregate, exchange. So it doesn't matter what language you write in.
It compiles down to the same thing.
It compiles down to the same thing, yes.
That's pretty cool.
So you use whatever language is easiest for you to write out what you want, and Scala will handle the rest. So I love SQL. I've been using SQL for about 20 years now, and I'm going to do the rest of this course in SQL.
Okay, cool.
Cool. So
I need to learn more SQL.
SQL's wonderful. But I'm completely biased in that regard. So the next video, we will give you a quick introduction to how to write SQL queries. If you already know how to write SQL queries, feel free to skip it. There won't be any Scala Spark specific stuff inside of there. But if you just want a refresher, then feel free to watch along, because SQL's fun and I love it so much. Alright, let's finish this video here. See you in the next video.
See ya.